is that it's all about perspective. And what I mean by perspective, it's all about the way that you look at something, which means that you have to understand the basics of what exactly are you looking at within a diagram. Now, we've done a lot of this before. Hello? No, that's fine. I figured because of the days, the times where I'm not worried about it. What happens a lot of times with trig here is that we've already worked about how to solve right triangles by using Pythagorean theorem. And we also learned in the past, last week or earlier this week, about how to work with the special right triangles when they're 30, 60s, or 45s. Now, what happens when they're not a special right triangle, you have to be able to know how to use what's called trig to solve for the missing side lengths and stuff. And it's a very simple procedure, but you have to understand why it's developed the way it is. So if you start with a right triangle, no matter what, you know in every right triangle two things, no matter what. The first thing is easy. You know where the right angle is because of that little square box. And the only other part of the right triangle you always know is what? The hypotenuse. Very good. Where's the hypotenuse? That's the opposite the 90. So these two parts of the right triangle are the two that you will always, always, always know. You may not know what the value of it is, the hypotenuse is, but at least you will know where it is located. Okay? Now, if you think about it then, in every single triangle there are 6 pieces, 3 angles and 3 sides. You now know 2 of the 6, a third. So there's not much left to worry about. So after you get that far, it's just a matter of what other information do you have to go on. For example, if you start here, and that's an angle. I don't know what it is. I have no idea what it is. But that angle, if you think about it, when you circle it, it's looking at that side, isn't it? When you're looking at something that is opposite you, it is looking to its side opposite. Also remember, angles are created from 2 sides. So the 2 sides that don't make up the angle, or I'm sorry, the side that doesn't make up the angle is called the side. Back out. There it goes. This is called the opposite side. So if I'm at this angle here, bless you, it's called the side opposite. I just abbreviate. Markers are missing. We will have hypotenuse, hypotenuse, opposite. And in a second here, we're going to have something called an adjacent. Adjacent would be the side next to you. So if I'm back at my angle here, the side next to me is an adjacent. Now, isn't the other side next to me a hypotenuse? Why do I call that an adjacent? Because it has to be a hypotenuse because it's across from a right angle. It supersedes it, okay? A hypotenuse is more important than an adjacent because in the grand scheme of things, since this right angle is here, this portion never moves. It'll never change because that side will always be the longest. It'll always be across from the right angle. Whereas if I was up at the angle on top, I'm looking down at the side opposite me. The side next to me is my adjacent. But if I flip-flop it and I start down here, what changes? This becomes my opposite, and the other side would be my adjacent. That's why I talk about the idea that trigonometry is all about perspective. It's about where you are within a triangle and what you're looking at. If you're able to label things from that, everything else falls into place rather quickly. Because there's not much formula work or anything to any of this, but it's understanding what it is that you have in front of you. Excuse me. All right, let me show you another example. So if I have something like this, I have some numbers, I have a variable, I have an angle. Here's what I'm going to do for this style each and every time, all day long today, and probably most of Monday. No matter what, I'm always going to start by circling the angle that's inside the triangle. And I'm not circling the right angle, though, okay, so don't worry about it. And in doing so, I then know that this angle is looking at that side. When the angle is looking at the side, what is that side called? Opposite. It's the side opposite. It's what it's looking at. Bless you. It's always looking at its opposite. That's the whole, like, remember how we wrote out 30, arrow, 60, arrow, 90, arrow? The reason why I was writing those arrows because that angle was looking at the side opposite. The 60 was looking at the side opposite. I'm doing the same thing here. That we always remember that the arrow points to a side opposite an angle. Which makes the 14 a what? Makes it the adjacent. And the x has to be a hypotenuse. That's what we're looking at doing here. We're looking at trying to come up with a way to label these things without making it too crazy. All right? That's really all. No, not yet. You don't know how. Not yet. Same deal. Same deal here. Basically for the next, I don't know, 2-3 weeks or so, everything we deal with will be in a right triangle, just so you guys know that. We will veer out of the right triangles probably closer toward the end of February for about a week, and then we'll get back into shapes, like polygons and stuff like that. But we do spend some time in non-right triangles as well. What do you think I'm going to say to do first? Circle the angle. Which makes that side of x its opposite. Very good. The 14 is it's a hypotenuse. Good. And the missing side with nothing on it is the adjacent. Okay. Now, the reason why I'm getting you guys to write all this stuff out is because it's going to show you what. Can I go to a clean one here? I don't want to go this far. It's going to show you what's happening with those 3 little buttons on your calculator. Because if you know which side lengths you're dealing with, you will know which of those 3 buttons that you're going to use eventually to solve problems. For example, we go back and redraw a problem. If I start at that angle of x, what am I looking at? I'm always looking at my opposite. There's always my opposite, which makes the one across from the right angle the hypotenuse. And then obviously the last but not least, this becomes your adjacent. So the 3 functions, the trigonometric function buttons that you have on your calculator are sine, cosine, and tangent. Okay? They're spelled sine, cosine, and tangent. That's how they're fully spelled out, but that's too many letters, takes too much space, buttons are small, that's why we just use those. Okay? So you just abbreviate it. That's why we don't worry about it. Now, each one of these trig functions is nothing more than a ratio of side lengths. And that ratio for each trig function is different. Right? For example, if I want to talk about the sine of some angle, the sine of some angle is always the ratio. Remember what ratio means? I'm saying it's ratio, and you're not even fun. What is it? More specific. Proportions to ratios set equal to each other. You're getting there. What's the ratio?
Like 4 to 3.
Okay, 4 to 3, or then you would say it as 4 over 3, a fraction. Okay. Remember, ratio is just a fraction. So the sine of some angle will always be the ratio of the side opposite divided by the hypotenuse. So if you're working with, in a triangle, and you know an opposite and a hypotenuse, you would press the button that says sine, and you would make it work. Obviously, there's a little more algebra involved than just that, but for the most part, that's what you're looking to do. Mark over here. Excuse me. The next one is cosine. Cosine doesn't deal with the opposite. Cosine deals with its adjacent. Cosine of some angle would be the adjacent over the hypotenuse. Now remember, it's all about perspective. If I'm here at this angle, my cosine would be adjacent over hypotenuse. If I'm up at this angle, this becomes my adjacent, but that stays my hypotenuse. So things can fluctuate depending upon where you are. Okay? Not all triangles are always written with the right angle on the left and the angle you're looking for on the right. That doesn't always happen. It's all about how things are moved around and understanding where parts are in relation to your angles. Excuse me. And then the last one then is tangent. And that's the ratio of the sides opposite, or side opposite the angle, divided by the adjacent side. Yeah, and x can be anywhere, honestly. This value x just means this x value is some angle measure, some degree measure. Okay? It's some degree measure. One quick thing to note, you never have to worry about finding the trig functions at the 90-degree angle, because if you think about it, excuse me. If you think about it, if I'm at the 90-degree angle, what side is opposite me at the 90-degree angle? But that's the hypotenuse, isn't it? Which one is my adjacent if I'm at the 90-degree angle? Is it the left or to the right? You don't know. So that's why we don't worry about finding trig values at 90-degree angles. You will in Algebra 2. They're called quadrantal angles, and you'll learn about that second semester Algebra 2 in that different trig unit. But you use the same premise of what we start with here. Okay? So if I go back to the triangles we were looking at here, and we just did this one, right? Yeah. We just wrote this one out a second ago. We said that this was the opposite, and this was the hypotenuse. Which of the trig functions work with opposite and hypotenuse? Sine. Sine. Sine works with opposite and hypotenuse. The other ones have hypotenuse, this one has an opposite, but this one is the one that has both of them. So basically what that means then is that I could have written this out as the sine of 42, because that's the angle, would equal x over 14. I don't know what that is. I don't know how to figure that out yet. But in the grand scheme of things, that's what we're starting to work on. Okay? We're labeling our so weird. We're labeling our parts and building ourselves out. Okay? Let's try another one. Wait, I look up, you're going. Yes, ma'am.
So we're not learning how to solve them,
Nope.
we're just
Nope.
figuring out how to set them up?
Too much. Baby steps. Baby steps. I'm in absolutely no rush to do any algebra today. I want you guys to understand where this comes from and how you set it up. Because if you get that down pat, the rest of it's easy. Excuse me. All right. So draw your diagram. Draw your diagram and start labeling like we have been. So I start by circling my 31. Your angle always is looking at the side opposite you. Which makes the 17 a what? Adjacent. Which of the three trig functions, therefore, work with opposites and adjacent? Tangent. So you write it down. The tangent of 31 is my opposite over adjacent. I don't know what it is, nor do I care.
Wait, how did you know? I don't know. I failed.
I just called it pants. I didn't know how to say the word pants, so I was dating.
My dad calls Holden's girlfriend fancy pants.
His girlfriend?
Holden?
Yeah.
Yes. Murphy, where have you been for the past 2 or 3 years?
He's been out of school for
A year.
I was 2.
No, he just graduated last year.
Oh, never mind. Excuse me. Again, what do you think we're going to start by doing?
Circling 38.
Yeah! Draw the diagram.
Yeah. Don't skip that one.
Sorry.
Yeah. Now you can circle 38.
Well, you don't want to get ahead of anybody else, okay? So slow down.
What did you do?
Nothing yet.
Oh, it's close.
I circle it. I was.
Oh, I'll send it in.
Oh. That's my opposite. I have no information there, so I don't care about it. Which makes the 17A and the XA. Look at it down a boat. Something like that going up there.
I don't know. He told me
Uh-huh.
that was right, so
So now, what trig function is it, Ms. Tope?
cos. Whatever.
Cosine. So that means that then the cosine of 38 is 17 over
Wait, why
x.
isn't it?
Because look what's up on top.
because a cosine is always adjacent over hypotenuse. Okay?
Why isn't it opposite?
I have no information here.
Oh.
I'm looking at I'm looking at what the information I have given. Let's say that this was a 15, and I needed to figure out, then I could use tangent or something, but if I had 15 and 17, I wouldn't bother using trig, because then I would just use Pythagorean theorem to find that, because it's quicker.
Okay.
But this is for, these types of problems are for when Pythagorean theorem doesn't work, and special right triangles don't work. This is the, if all else, or in case of a fire break glass type thing.
Wait, I have a question.
Yes, ma'am. Yes. Yep. And remember, these never move. Adjacent always in the numerator. Hypotenuse is always in the denominator. Opposite's always in the numerator. Hypotenuse is always in the denominator. These will never move because it says the sine is this ratio. The cosine is this ratio. Tangent is this ratio. Don't worry about flipping. They never flip the ratios. They will always stay like that. Otherwise, you make new trig functions and you don't want to do that. So take a couple minutes and do the exact same thing with these four. Please. First one, what do you use? If you circle it, this is your opposite hypotenuse. What trig function is opposite hypotenuse? Sine of 24 is x over 20. That's it. One below it. 19. Circle it. It looks at its. The x value is a what trig function? Sine of 19 is 12 over x. Okay? Because that's what you're solving for. Circle the 40. 17 is its. The x is a what trig function? Do not flip-flop the x's, guys. Don't flip-flop them. They have to stay wherever you say it's the hypotenuse or adjacent, wherever it winds up being. Excuse me. And the last one.
It just doesn't look right.
The last one. Circle the 41. X is its. 12 is its. What trig function? Tangent. And that's what this looks like. So, what I have for you guys is basically some problems that look exactly like this. I pretty much is the same.
If I go like this, then it No, I like what it is. And then if you don't, then it's I don't know which one.
Excuse me, pardon me. You're excused. Alright, so what I want you guys to work on. Guys, what I want you to do for homework is nothing more than the following. Yes, ma'am.
Hurry up and hand me the paper.
Guys. Remember, it's always about where you're sitting, okay? That's why we label, because your angle is always looking at a side opposite, which makes the other one an inches. All right, take a look at what we do. This is my expectation for what you are to do on your homeworks. Because the more that you set this up, And the more that you show what you're going to do prior to doing it, this comes into play with calculator work here next week. If you show me what you're doing, I know that you know what you're doing. If you just start pressing buttons arbitrarily, I don't know what you did wrong. But if you write down what you're about to do, I can figure out if you just press the 2 instead of the 3 or something along those lines. But this helps you get along those roads. So here's what I expect you to do for the problems on the back. Circle the angle
Wait, we're doing the whole back?
and label your stuff. For each problem, circle the angle, label your sides, and then figure out what trig function you're going to use. Which one am I going to use here? I have adjacent and hypotenuse, which is cosine. So the cosine of 55 is 14 over x. And that's what I'm going to do for all of these. Just on the back, yeah. Okay? We've already done most of the front in our notes.
Oh, thanks.
Oh.
Put it up. Raise it. All the way.
Yes, ma'am. We've already done about 9 of those in our notes. Don't worry about it. Okay? So, work on those because then come Monday, guys, come Monday, we will start to talk about how we are able to solve for x. Now, the value of x to start with is either going to be in a numerator or a denominator. We won't have to solve for x yet as an angle. We'll get to that maybe by the end of next week. But it's a matter of, basically works out to be a 1 or a 2-step equation for us to solve. Okay? Don't overthink it, but I cannot stress the importance enough. Write this down on the sheet of paper in front of you. That way you have it. Also might not be a bad idea to draw a little diagram of what a triangle looks like so that you remember that if you're at an angle, you're always looking at your opposite. Angles always look at opposites. Okay? Angles always look at opposites. Are you mocking me? Wow. Got a tough crowd around here. Yeah, give me 1 second to save this, and I'll be right there.